You know, in statistics, we always hear about the gold standard, simple, random sampling. But what happens when that's just not enough? Today, we're going to open up the Professional Statistician's Toolkit and look at how they really tackle the challenge of understanding huge, complex populations. So let me ask you this. Is a random sample always the best sample? I mean, it seems like it should be, right? Random feels fair, and fair feels accurate. But here's the thing. While we think of random as being unbiased, the real goal is to get a sample that's truly representative. And sometimes leaving everything up to pure chance can actually lead you down the wrong path. Just imagine you're doing a big national poll. If you rely on pure random chance, it's totally possible, maybe not likely, but possible, that your sample could end up with 0 people from a smaller state, like Wyoming. Now, your sample is technically random, sure. But does it accurately reflect the entire country? No way. So how do we prevent that kind of thing from happening? How do we make sure Wyoming gets a voice? Well, our first tool is designed for exactly this. It's called stratified sampling, and its whole job is to guarantee that every important subgroup gets a seat at the table. The way it works is actually pretty smart. First, you slice your whole population into these separate, distinct groups. We call them strata. You could group people by age, by state, any important characteristic. Then, and this is the key part, you do a simple random sample inside each and every one of those groups. This makes sure that nobody gets left out just by the luck of the draw. This really gets at a fundamental shift in thinking. A simple random sample is based on hope. You just cross your fingers and hope you get a diverse group. Stratified sampling, on the other hand, is based on a guarantee. You decide up front, nope, I'm going to survey exactly 50 people from this group, and 50 from that one, and 50 from the other. You're literally taking luck out of the equation to ensure you get that balance. Now, the secret sauce to making this work is how you build those groups. The whole idea is to make each group, each stratum, internally homogeneous. That's just a fancy way of saying everyone inside a single group shares some important trait. You put all the Democrats together, all the Republicans together, all the people in one income bracket together. The power comes from grouping like with like before you even start sampling. Okay, so guaranteeing representation is amazing, but sometimes your biggest problem isn't fairness, it's just logistics. I mean, how do you efficiently sample from a massive customer list or a population spread all over the country? For that, we need tools built for speed and scale. And that brings us to systematic and cluster sampling. Systematic sampling is, well, it's pretty elegant and super practical. You just need an ordered list of your whole population. You figure out your sampling interval. We call it K, by dividing your population size by your sample size. Then you just pick a random starting spot and grab every kth person on the list. So if your interval K is, say, 20, you might pick person number 12, then person 32, then 52, and just keep going like that. But, and this is a really big but, this beautiful simplicity has a hidden weakness. We call it the pattern trap. See, if there's some kind of hidden cycle in your list that just so happens to line up with your sampling interval, your results can get incredibly messed up. Think about a factory conveyor belt. If a machine makes a bad part every 10th time, and your sampling interval is also 10, well, you might end up with a sample of only bad parts, or maybe none at all. All right, our next efficiency method is cluster sampling. Now, just like stratified, you start by dividing the population into groups, but this time we call them clusters. But here's the huge twist. Instead of sampling a few people from all the groups, you randomly pick a few entire groups, and then you survey every single person inside those chosen groups. And this is the main thing you have got to remember, because it's where people get confused. Stratified sampling is sum from all. You take a few people from every group, because your goal is representation. Cluster sampling is all from some. You take everyone from just a few randomly chosen groups, because your goal is efficiency. And that means the groups themselves are built differently. Strata are homogeneous, all similar people. Clusters are supposed to be heterogeneous. Each one should look like a mini diverse version of the whole population. So we've looked at these methods one by one, but in the real world, when you're talking about massive national surveys, the pros don't just pick one. Oh no, they layer them together in a really sophisticated way called multi-stage sampling.
Let's walk through a classic example. Stage 1. A researcher might stratify the country by state. That guarantees you get geographic representation. Then, Stage 2, they could use cluster sampling to randomly pick a few counties inside each of those states. And finally, stage 3. They might use simple random sampling to pick specific households within those chosen counties. You see, each stage narrows the focus, all in a statistically sound way.
Okay, so far, everything we've talked about is what we call a probability-based method. That means everyone in the population has a known, non-zero chance of being selected. But there's another approach you see all the time that just throws that whole principle out the window. And it's so important that you know how to spot it. It's called convenience sampling, and it's exactly what it sounds like. You survey people who are just easy to get to. You know, polling your friends, your classmates, or the first 50 people who walk by you at the mall. The absolute most important thing to take away here is that this is not a scientific probability-based method, and because of that, you can't reliably generalize the results to anyone else. So why is this such a disaster? Well, let me paint you a picture. Imagine you stand outside a library to survey people about their reading habits. What kind of people are you going to find? People who like books and libraries, right? You will completely miss the opinions of everybody who doesn't hang out at the library. This introduces a massive bias that can make your data totally worthless for drawing any real conclusions. It's a powerful reminder that in statistics, how you pick your sample is every bit as important as the questions you end up asking.